Cell membrane regulates the movement of molecules from outside of the cell to inside of the cell through the process of membrane transport, which can be active and passive. Here is our experiment that explains how diffusion and osmosis happens.
Hi guys, this is the first experiment of the activity and it is all about diffusion. First step, fill the glass with water to 3/4 full. Second, pour the baby oil, vegetable oil, or any clear oil into the glass of water for about half an inch high, and in this case, I used baby oil because of the availability of resources. Third, using a stirrer, slowly stir the water and oil mixture. There are small circles forming and rotating in accordance with the flow of the swirl. Fourth step, allow the mixture to stand for about a minute after mixing. And then slowly add one small drop of liquid food color to the water oil mixture. From here, the food color did not scatter or disseminate, but formed into a droplet-like sphere which is gradually settling down to the bottom layer of the baby oil. After dropping some liquid food color into the water oil mixture, the first droplet of food color did not totally pass through as some of its contents remained at the bottom of the oil layer, whereas the food color that passed through the oil layer began to spread, in which it forms like a downward umbrella, slowly disseminating.
The reason for this is that oil does not mix with water because oil is made up of non-polar molecules while water are made up of highly polar molecules, and polar and non-polar molecules don't mix. But instead of mixing into the water, the oil forms a bubble and the bubble eventually floats back to the surface. Second, the baby oil floats to the water because of the difference in the densities. Oil has a lower density compared to water. Lower density fluid floats on top of higher density fluids. On the other hand, food coloring has a higher density than oil, and it is a polar molecule, so it won't mix and scatter in the oil. So when the food coloring is dropped into the oil-water mixture, it leaves the food coloring to stay together in the oil, making it highly concentrated. Since water and food color are the only same polar molecules, food color is soluble to water and can mix and scatter. The moment the food color comes in contact with the water due to the eventual pull of gravity, the food color diffuses as it is polar and soluble in water. The water has no concentration of food coloring, which means that the flow of food coloring from the oil to the water comes from the higher food color concentration to a lower one. This explains how diffusion is taking place by the movement of food color in a high concentration to a lower concentration. Given enough time, the food coloring will mix thoroughly with the water evenly.
So today, I will show you how does the temperature affects the diffusion rate. But first, you're gonna need these following things. So let's start. First, fill the glass A with cold water to 3/4 full. And then, fill the glass B with hot water to 3/4 full. Next, slowly add 1 teaspoon of coffee to each glasses without mixing or stirring carefully. Observe what happens. Result shows that the coffee in glass B, which contains hot water, diffuses faster than in glass A, which has a cold water. This tells us that substances diffuse faster or has a faster rate of diffusion in higher temperature, as molecules in substances with higher temperatures has more and faster kinetic energy that keeps on moving and colliding with each other, results to a faster diffusion rate. Thus, we can conclude that the rate of diffusion is affected by temperature and that it is directly proportional. The higher the temperature, the faster the diffusion rate.
Experiment 2, osmosis. The materials that we will be going to need are 3 eggs, 3 glass, white vinegar, salt, water, and 3 spoons. So let's prepare these materials and then we can move forward on experimenting with these 3 eggs, and let's witness the osmosis that will be taking place. Place 1 egg in each cup and pour enough amount of vinegar, and you will then see bubbles will start to form around the egg, and then soon it will float. To keep it submerged, we use a spoon to hold it down.
After the egg was deshelled and soaked for 8 hours in both glass A and B, there is an increase of egg size in glass A and a decrease on glass B. This is due particularly on how osmosis operated on both eggs in the two solutions. The egg that you put in glass A shrinks, while the egg that you put in glass B will swell particularly because the egg's membrane is permeable to water. Substances that can pass easily through the membrane of the egg will move through the membrane from the side where they are at a higher concentration to the side where they are at a lower concentration. Water is the only substance which can go in and out of the membrane. Salt and egg contents like proteins and other biomolecules should be diffusing, but they cannot pass through the membrane, for the membrane is semi-permeable. This is how now the concept of osmosis will work, as water will move in response to the solute from higher concentration to lower concentration. The salt added to the water in glass A solution makes the solution hypertonic as you soak the egg inside. The salt increased the amount of solute outside the egg, thus the solution now has a lower concentration of solvent and a higher concentration of solute outside the egg compared to the higher concentration of solvent and lower concentration of solute inside the egg. Because of this, water now will move out of the egg in order to equalize the concentration of solvent in both outside and inside the egg, which causes the egg to shrink. Glass B, on the other hand, will have a hypotonic solution as you soak the egg inside a glass filled with water. Because of the water solution, outside the egg now has a higher concentration of solvent and a lower concentration of solute compared to the inside of the egg, which now would have a lower concentration of solvent and a higher concentration of solute. Because of this, water now will move inside of the egg in order to equalize the concentration of solvent in both outside and inside of the egg, which causes the egg to swell.
Here are our conclusions in experiments A, B, and C. Experiment A, diffusion of particles or molecules comes from a higher concentration to a lower concentration. Experiment B, temperature affects the rate of diffusion. The higher the temperature, the faster the diffusion, which is directly proportional. Experiment C, water in a semi-permeable membrane moves through osmosis from a higher solvent concentration to a lower one, and in response to the solute. Hypotonic solutions cause the cell to shrink as water goes out of the cell, while hypotonic solution cause the cell to swell and expand as water moves into the cell.